Hello friends, this is Frank from Germany and welcome to the next video session. The topic is how can we mill a PCB with a chili pepper. The chili pepper has a feature, it's a very nice feature, Eagle import feature, and we want to use this. You will see all steps you need to mill a PCB. I want to show you experimental PCB. You see this in the background. And yes, let's go. Don't speak about it, do it. Here you see a normal MOSFET driver. Too short to say it's only an optocoupler. It's isolated. Yes, he switched this MOSFET on. It's a little SMD MOSFET with 3 ampere and up to 20 volts, I think. Very nice. And I need this for my winter project to make a pick and place machine to, switch on solenoid. I hope I speak this correct. I can show you this. The solenoid, wait, I have this here. I need this for a vacuum pump. Here you see this. It's very cheap. I bought this for $1. Let's use it. You see this with this little ventil here and so on. And this will drive with 12 volts. Need maybe here you see this now. Need maybe 250 milliamps, but too much for a microprocessor, but for this MOSFET driver, it's possible. Now, we want to make this PCB in the Eagle. I use Eagle very much and a lot. And now we show this PCB here. It's 25 millimeters width and 25 millimeters high. You see here the optocoupler, it's a little bit bigger. And this little thing here, it's a MOSFET. Very small, very cool. We have a little LED. He can switch on when it's on, switch off when it's off. Also, you can dim something. Yes, 12 volts. Maybe you can dim a halogen lamp or so, 3 amperes. It's possible. Okay. The first one is you have to decide how big is the signal wire. Yes, because we need a little bit bigger signal wires because the milling is not so correct. I test this with a lot of tests. I published this in a Google Plus group, and sometimes it's possible to see the wires, but yes, we make a little bit bigger. You must go to the net classes. It's under edit, this point, net classes, and you can say, okay, my wires have a width about 20 mils. I know 40 mils, it's probably 1 millimeter thick, and we take 20 mils, 9.5 millimeter thick. I think that's okay. You say okay. And now we can use the autorouter. So this one. Check. Never use an existing job. I don't know what is this for a crazy thing, but it doesn't work for me. We want only route on the one side, on the top side, and the effort is high. And let's go. We let him calculate. And you see, we are lucky. Here he calculated a little bit more because it's an optimized autorouter. Here's also, and this looks very good. Yeah. And then we say evaluate. And we are not lucky. We have one little air wire. You can see here, this is a little air wire. And if we looking for the preference for this, you see that's a GND, it's ground air wire. The solution is simple. You need a little wire from here to here. But we have 9.5 millimeter thick wires. We use a little bit smaller. Drive the signal wire here. Start point. Let's go. It's the wrong side. You see this on the blue color. We need the top side. Top. So, and now we need a little bit smaller. 9.254. It's 10 mils. And now we can go to this. Nice. So now we must move this little bit in a little bit of the middle from this SMD component here. And you push the Alt. So, maybe so, and I need the next corner. Wait a moment. Here, okay. So, and make it a little bit so. This corner, so it's straightforward. Very nice. You see, this is our, we can say this is our dangerous area, but no risk, no fun. And this wire we make a little bit bigger. We go to 9.4. It's okay. We can also say 9.5 action. And this one also, this one also 9.5. 9.5 thick. Okay, the rest is doesn't care because it goes here around. When you say the rat's nest, then you can see, okay, ground is everything good. And here is in German on the lower left corner, you see rat's nest, nothing to do. And nothing to do means, okay, you are finished. Okay, now we save this little work and we can go to Chilipeppr to import this. Now we are in Chilipeppr. Please go to this URL chilipeppr.com/xpix and make a force refresh true, because sometimes I work on this feature and it's better you use the last version from this. And some bugs fixing and so on. It's better to use this. Now we go to our MOSFET board and make a drag and drop to the browser window. Wait a little bit. My PC is not so fast. The first drag and drop doesn't work, but now the second works. Now you see the board here in Chilipeppr, very nice. You can check all the wires. Yeah, this is on layer top, and the signal wire has a name N$4. But here's our GND. We can't see this. We must a little bit move. Yes, so. And you can see it's very small. He doesn't calculate this. I don't know why. Because GND goes through here, and it's okay. We can do this. So very nice, but we must change some parameters. The first one is I have an end mail. It's a V end mail. Yes. It has a spiral. And it's 30 degrees. And I calculate a little bit, and the end of the milling part is 9.2 millimeters for me. You must change this for you. You can read this little help text here, and maybe it helps you. And I have a normal FR4 PCB plate. This means 9.935 millimeters is a copper side thick, and it's okay. The inflate SMBs by one, I can try this, yes, no problem. Clip wires, Inflate pads, no. Inflate vias by, I don't have vias. And the solid line is also 9.2. And now we can make a refresh. And you see it's a little bit smaller, yeah, everything, it's a little bit smaller. Here we have some problem places, this one here, but you see the pad is very thick and it's okay. Also here maybe, but everything looks good. Very clear. Very cool. You have here also little problems. We can check this after the milling, but I think it's okay. So let's go. The next tab is G-code. G-code is very important because here you decide how deep will the end mill go in the material. And I use mostly the example 9.97 millimeters. It's also good for my mill. It's very good. Maybe you must change this for your mill, you know. But I can say the spiral end mill. It's very nice. Yeah? It's very stable and robust. And sometimes you make some mistakes and you have a broken end mill. It's not very nice because cause some bugs. But the spiral end mill, it's a very good thing. I want to show this you later, but now you can let the feed rate now. 80 feed rate to plunge into copper. Also 30, it's okay. Clearance for the Z-axis move 1 millimeter, it's also okay. Then drilling holes, yes, and mark holes for drilling. It's a feature that he make a little mark in the middle from the future drill. And for the drill, it's very nice because he used this mark to be in place. Yes. Sometimes the material is so hard, the drill will dancing around this hole, and this is not very good for your drill. Also not good for your material. Yes. Use this feature. It's very nice. Also, if you want to drill this holes manual, also very nice. You make in the middle a little point and you have a good center for your drill. Use the board depth, logo, and maximum hole diameter to drill. If we have a hole what is bigger as 2 millimeters, then he want to use the end mill to drill this hole in a kind of spiral. Yes. Because we don't have so big driller, yes, and maybe you want to put your PCB in an enclosure or so, then you need a bigger hole, maybe 3-4 millimeters for M3. I don't know the right English word, Schraube, and then the end mill for that make also the dimension. To cut out this PCB, use this to make this hole. Let's go. Feed rate to drill 200, it's okay. Board dimensions, I use a diameter tool, a tool with a diameter of 2 millimeters on the side here. Yes, he make this quadrat. He drill on the side with 2 millimeters. And the depth of cutting out dimension is 1.7 millimeters, is 9 millimeter more as the thick of the board because you want to cut this out and it's better. Now a step down for cutting dimension, feed rate for cutting dimension, it's okay. So now we are finished and we can say, okay, I like this, send G-code to workspace. You wait a little bit and now you see everything, it's now in G-code. You see also the moving from the driller. He go up, down. He make also these marks, yeah. And very nice. You can watch this from all sides. Also very nice. Very important is check the drill deep. Here you see this blue line must a little bit deeper as a gray line, and then you see, okay, this is a 9.97 millimeter deeper. Yeah, this is correct and it's okay. So now you can check out, switch off this eagle BRD import because it's finished. And the next step is to make auto level. Auto level is a very nice feature. He make a matrix over your piece of work, and you can say, okay, every 5 millimeters in the high, I want to make a test with my probes stick. You must put in your end mill for drilling the wires in your spindle, and then you must put the ground or the one side from the touch plate to the PCB and the other side to the driller. I want to show you this in the underground. I have my machine underground, but now I can demonstrate how it works. So steps every 5 millimeters. You start at null point null, and the end is 20 millimeters. 20 millimeters. Hey, look, it's very, very small. This very nice board. Unbelievable. Okay, 20 millimeters in quadrat. Clearance high 1.5. I can say, please let the values. So John make a very good work with this values. Also the probe feed rate, don't make it faster. Then you get an alarm error. In my case, 5, it's okay. You have this time. And the Z fine is safety high. I make 25. Okay, this was the first episode from my video session. And the next time we are on the underground with the other camera, and then forward how we can mill this PCB. And I hope you like it, and see you.